called enthalpy. H is enthalpy. H means enthalpy. H is equal to enthalpy. So enthalpy can be defined as the sum of the internal energy of the system and the energy arises due to pressure and the vacuum. So this is the formula for enthalpy, right? Next, enthalpy is definitely a state function, beta. It's a state function. That means enthalpy depends upon initial and the final, but not on the path. How the change is occurring, it does not depend. Enthalpy depends on initial state and the final state. Being a state function, we can write now H is a delta H. Now what is extensive property? Extensive property means this enthalpy depends upon the quantity. If I take more quantity, I will get more enthalpy. Understood here? Why? Because internal energy is a extensive property. More matter, more quantity, more internal energy. More gas, if I take quantity of gas, I will get more pressure. More amount of gas I will take, what happen? More volume I will get. So all these are extensive properties. So even enthalpy also what? Extensive property. Depends upon the quantity of the matter. Now I can write the enthalpy now. H is equal to U plus PV, because being a state function, all are what state functions here. So I'm writing like this here. Delta H, isn't it, is equal to delta U into delta PV, I can write. Now what is initial state? H1 is equal to U1 plus P1 V1. What is final state? H2 is equal to U2 plus P2 V2. Initial state, final state. Because of state functions these are. Now delta U is equal to change in the enthalpy. What is the meaning of delta H, beta? Change in the enthalpy can be given by delta H. That is equal to H2 minus H1. Final minus initial. H2 is equal to what? U2, isn't it? Plus P2 V2 minus H1 is equal to what? U1 plus P1 V1. Then what we get here? You take U1 and U2 same side. Then what we get? Isn't it? Otherwise, first you will do like this. Minus into plus is equal to what? Minus. So write down minus U1 minus into P1 V1 is equal to minus P1 V1. Now what we'll do? U1 you bring here. Isn't it? So what we get? U2 minus U1. Then what happened? P2 V2 minus P1 V1 we get. This is the expression we get once if we send what happened? U1 over. U2 minus U1 is equal to what? Delta U. You know that one. U2 minus U1 is equal to delta U. Now P2 V2 minus P1 V1 is equal to delta P. Right? So we got this equation like this. Delta H is equal to delta U plus what happened? Delta PV. Here delta is nothing but what? Change. Isn't it? From final to what? Initial. Now suppose the reaction is done at constant pressure. You are just assume that the chemical reaction is taking place at constant temperature, pressure actually. In that case, what happens to this? What happens to this formula? Now, in that case, if constant pressure we are maintaining, in that case, P1, P2 will be same, no? This is at constant pressure. In that case, no change is occurring. I am not saying P is equal to 0 beta. What I am saying, constant pressure means initial, what is the pressure? For example, 1 atm pressure is there. And final also what? 1 atm only. That means pressure is constant here. Correct? Then, in this case, what happened? I can write the expression I can write like this. Delta U plus P into delta V. Why? Because only volume is changing here. Only what changing here? Volume is changing, but pressure is not changing. So at constant pressure, you can write expression like this. You can write this expression. But most of the reactions will take place at constant pressure. Therefore, this expression will take place for most of the reactions. So heat content of the system at constant pressure can be given by this formula here, right? Now here what I am taking QP. What is QP means? Heat you are expressing at constant pressure. QP means what happened? Pressure is constant, heat content of the system you are expressing. QP is nothing but what? Heat content of a system at constant pressure. So now what I am doing here, this delta U, I am replacing with what? QP. Why? Because this is the energy, internal energy of the system. Correct or not? Delta U is nothing but internal energy of the system. The internal energy of the system, the energy you are taking in terms of heat now. The energy you are taking in terms of heat. Then delta U is now taken as what? QP now. Right? So you are writing here what? QP. You are not representing a delta because heat is what type of function, beta? It is path function. So don't use delta over here, right? So for solids, liquids and gases, we can write delta H is equal to delta U plus P delta V. This is what, beta? At constant pressure. So this is general equation we are using because most of the reactions at constant pressure only. This is a general equation you have to remember. So for solid, there is a negligible change in the volume at constant pressure here. Okay. So what is the change for what? Solids, isn't it? What happen at constant pressure, solids volume does not changes here. So delta V becomes 0. In that case, P delta V also becomes 0. Delta H is equal to delta U. This is for what, beta? Solids. Why I have taken for solids delta H equal to delta U? Because for solids, the change in the volume for solids, if you observe, the change in the volume is always what happened? Neglectable from initial to what? Final. Change in volume neglected. Neglected. We are neglecting what? Why we are neglecting? Because very small change are occurring for solid states here. Right? Next, if you observe what happened, liquids. For liquids, there is a negligible change in volume at constant pressure. Same thing we are observing for liquids also. The change in the volume also is neglectable. Again, delta V is equal to 0. P delta V equal to 0. For liquids also, delta H is equal to delta U. Same thing we are observing. And finally, for what? Gas molecules, generally what happens, the change in the volume cannot be neglected here. In general, enthalpy change is given by, for this one, this P delta. This equation we are using for what type of things, beta? Gaseous reactions. For gaseous reactions. This entire the formula we are using for what type of substances? Gaseous substances. Delta H is equal to delta U plus P delta V. For solids and liquids, the formula will be delta H is equal to delta U. Why? Because the change in the volume is what? Negligible here. Right? Now, if you observe again this one. Just a minute. Now we observe what happened. Change in the volume V2 minus V1. Delta V always equal to V2 minus V1. Then substitute this one like this by multiplying PV2 and PV1. We are getting this expression. In terms of number of moles, we can convert this one now by using ideal gas equation. Everyone knows ideal gas equation. PV is equal to nRT formula. Everyone knows this one. Now, according to this, PV is equal to nRT. PV is equal to nRT. Now, what I have taken, temperature is constant, R is constant, pressure is constant. I told you initially only pressure is constant. Now, what is variable here? Volume and moles are what? Variables. Therefore, you take for this one P1, PV1, N1 RT and PV2, N2 RT because these two terms are variable terms. Remaining are constant. Correct or not? Now, based upon this one, this formula, ideal gas formula, what we can generate in this case? Based on this formula. Now, PV2 is equal to how much, beta? PV2 is equal to how much? N2 RT. PV2 is equal to N2 RT. Substitute here. Similarly, PV1 is equal to how much, beta? N1 RT. Substitute over here. Now, when you substitute, what happens? You are going to get N2 RT minus N1 RT. Now, N2 minus N1, isn't it? N2 minus N1, RT you take common. When you take RT common, what happens? RT into N2 minus N1 we get here. Now, what is this N2 minus N1? Delta N. Delta N for, because all things we are expressing for what? Gas molecules. For solids, liquids, the formula will be delta H equal delta U. So, for the gas molecules only, I have taken this formula. So, this is the formula for what? Delta H is equal to delta U plus change in the number of moles of gaseous products minus reactants here into RT. What is the meaning of delta Ng beta here? Let me see this. Delta Ng is equal to what we are going to get? Number of moles of gaseous products minus number of moles of gaseous reactants always equal to delta. For example, I have taken this formula. All of you see this formula. Nitrogen plus 3 moles of hydrogen gives rise to 2 moles of ammonia. All are gaseous molecules. This is important beta. All of you please listen carefully. Now what is delta and beta? Anybody? What is the mean for delta n in this case? What is delta and beta in this?
So -2.
Very good. -2 only, because you have see number of moles of products. How many moles are there on the products in gaseous state beta? 2. Write down here 2 minus. How many moles in the reactant side in gaseous state beta? 3 plus 1, 4 moles. Therefore, it will be. For example, if I take this one, calcium carbonate converting into calcium oxide plus carbon dioxide. This is solid. This is also solid. This one is a gas. Now, again, delta n is equal to what will be the formula? Number of moles on product side. How many moles are there in the product side in gas state beta?
2.
Only one only. In gas state, because for solids, this formula does not applicable beta. Because for solid, which formula we are taking? Delta H is equal to delta U only. Don't take for the for solid. Only take gas molecules only. Therefore, 1 minus 0 that equal to 1 here. That should be better. Only gas molecules we have to consider, not what liquids, not what solids. In this way, we can calculate the delta n. So easily we can calculate by using this formula. Internal energy we can calculate, and enthalpy also we can calculate. So all of you remember this formula. Now one more thing also I can explain here. If delta n is equal to 0. Now what happens beta? If delta n equal to 0, what will be the formula here? The formula becomes what? Tell me anybody. If delta n equal to 0 means
Delta H equals delta U.
Gases and reactants both are same. In this delta H equal to delta. Now when delta n is less than 0 or negative if we get. In that case, what will be the delta H delta U relation beta? Less than. When delta n is greater than 0, that is positive. If delta n is positive, like this is a positive one value. Delta n is positive. In this case, delta H is greater than delta U beta. So for this reaction, delta H is greater than delta U. For this reaction, because delta n is negative, so delta H is what? Less than delta. This type of questions you may get in the multiple choice questions. They will give the reaction beta. So you have to calculate the delta n, whether it is negative or positive. Consider only gaseous molecules. So definitely we'll get what is the relation here. Delta, 2, 3 relations will be there. Delta H equal to delta U, delta less than delta U, delta H greater than delta U. 3 relations will be there for what? Delta n equal to 0, less than 0 or greater than 0. Right? So this is about what? Expression what? Enthalpy. Can you give the answer for this one? Enthalpy change during a reaction does not depend upon.
Option D.
Change does not depend upon what? Number of steps in the reaction. It depends upon what beta? Initial and the final state. Enthalpy change depends upon what? Initial and the final state. What is initial? What is final? How many steps? We don't consider that one. Because it is a state function, right? For gases, enthalpy change is given by. For gases, what formula we can take beta? Just now we discussed the fourth problem. Properties of the system, if you observe what happened, already I told you extensive property. It depends upon the quantity. So more quantity, the property also will increases here. Let us consider a beaker here. I have taken a beaker. Now I have taken what happened 3 ml, 5 ml, 7 ml, 8 ml. The mass of the beaker remains same. The mass of the beaker remains same in this case. Because as volume increases, what happened? Mass also increases here. It depends upon the quantity. So what I mean to say is certain properties of the system whose magnitude depends upon the quantity of matter. More quantity, more volume we are going to. So volume is which type of property?
Extensive property.
Examples: mass, volume, surface area also. More quantity if you take, it will take more surface area. Internal energy, that means energy. Energy will, all energies are what? Extensive properties. Enthalpy, entropy, heat capacity, etc. all comes under what happen? Pressure. Pressure also comes under what actually? Extensive property. What is intensive means it does not depend on what quantity. So I want to check the temperature of the water beta. I want to check the temperature of the water. Okay. Now I have taken the temperature of water, a glass of water. And now I am checking the temperature of what? A bucket of water. Or I am checking the temperature of what? Whole water body of the water. Then the temperature will be same or different? Tell me beta.
Sir, same.
Same.
Same only. Therefore, temperature will comes under which property beta?
Same.
Intensity. Right?
Sir.
Temperature like boiling point, isn't it? What is just freezing point? All this comes under what happened? Intensive property. Okay. Now, certain properties of the system whose magnitude does not depend upon the quantity of the matter. See, here pressure is given. Generally, what happened? But why I have taken pressure here? Because see, actually, what is the pressure? Atmosphere condition. What is the pressure beta? Atmosphere condition. What is the pressure beta? In atmosphere, it is 1 atm pressure. For that, are you taking the quantity? For that, are you taking the quantity here? I want to calculate the pressure at atmosphere. It is around what? 1 atmosphere. Correct or not? What is the atmosphere pressure beta? 1 atmosphere. Correct or not? So for calculating the pressure, in that case, what will take here? Atmosphere pressure will be 1 atmosphere. But what happens, if I take what happened, more quantity, by putting a piston here, taking more quantity here, what happens? Pressure will increase on the system. Right? On the system, but not of the system here. So you can take pressure from the system, I am saying here. The pressure from the system will be what? Constant with respect to what? Quantity here. But if you put more amount of weight on the system, what happened? On the system, pressure will be increased, but not by the system here. Understood here? Density always will be, density of water will be how much better? Density of water will be how much better? 1 only always.
7.
Density is equal to weight by volume beta. Now I have taken 1 gram of water. Now what is the volume of 1 gram water? 1 only. 1 ml. So 1 only we get. If I take 1000 grams of water, the volume will be how much here? 1000 ml here. So it will again get 1 only here. So density of water does not depend upon what? Quantity here. Viscosity, refractive index. Now heat capacity is what beta? Heat capacity is what? Extensive property. But molar heat capacity is what? Intensive property. Whenever if we multiply anything with mole, then the extensive property will convert into intensive property. Heat capacity is nothing but amount of heat released when you change temperature 1 degree Celsius. If you take more quantity, what happens? You will get more amount of heat. But molar heat means what? For 1 mole only. For 1 mole only. So it is the intensive property. Concentration. Concentration is definitely what happens? Intensive property. E0 cell, pH, melting, boiling points, vapor, surface tension. Surface area is different beta. Surface area is extensive property, but surface tension is what? Intensive property. Vapor pressure, intensive. Now if you observe, mass is what type of property beta? Mass.
Intensive, sir.
Extensive.
Extensive.
Extensive property. Volume is what type of property? Also extensive property. Both mass and volume extensive property. When you divide both extensive properties, extensive and extensive property, the resulting will be a density. Where density is what type of property here? Intensive.
Intensive.
Divide two extensive properties, the resulting will be what here? Intensive property. Best example is the density for us. Similarly, when you take heat capacity, which is a extensive property, but multiply this one with number of mole. If you consider this one for mole, 1 mole, molar heat capacity. Now this becomes what? Molar heat capacity? Intensive property. Right? Can you tell me the better answer for this one? Surface area.
Extensive.
Extensive. Right. Which is the intensive property better?
All of these.
All above.
Right. Actually, heat capacity is not there in the syllabus. Better heat capacity, they reduce the syllabus. Heat capacity is not there. Just I will explain what definitions only, but I don't go in detail. What is the meaning of heat capacity only I will explain. Remaining, no need because it is not there in the syllabus. Heat capacity is removed. Now, the amount of heat required to raise the temperature by 1 degree Celsius of a system is called what? Heat capacity. For example, our ice is there. I've taken ice. Now I am heating this one. Now ice is converting into something. What happened? Little bit what happened? Water. Slightly what happened? Water. Okay. Now here, how much heat I am supplying here and how much temperature I have heated here? Only 1 degree Celsius. For example, 0 degrees Celsius. This is what actually around 1 degree Celsius. 1 degree. So how much rise in temperature took place here? Only 1 degree Celsius. Then the heat we are supplying is called what? Heat capacity. The amount of heat we are supplying to rise the temperature how much? By 1 degree Celsius, then that is called heat capacity. You can supply, you can increase even 5 degrees Celsius, 10 degrees Celsius also, but you don't get the definition. For getting the definition, I have taken 1 degree. If I take 1 degree only, I will get the definition. You can increase that one what? 5 degrees Celsius, 10 degrees Celsius, no problem. Right? This is the definition better. So the increase in the temperature is directly proportional to that. That means if we supply more amount of heat, more temperature will increase or not. If I supply what happened 100 kilojoules, something what happened 1 degree Celsius, 200 kilojoules, 3 degrees Celsius. Like that what happened, more heat if you supply what happened, more change we are going to get. Yeah, isn't it? Now here, remove this proportionality beta and put here C. Now C is equal to heat capacity. Now if you observe here, if delta T is equal to 1, then what becomes beta? It becomes what? Q is equal to C. That means amount of heat you are supplying is now equal to what here? Heat capacity. The heat you are supplying is equal to heat capacity when if this delta T is equal to 1 degree Celsius. If delta T is equal to 1 degree Celsius, then Q is equal to C. Heat capacity, now C is equal to heat you are supplying. So now why I have taken here 1 degree Celsius, I think you understand. If we take 1 degree, what happened? Then Q equal to C, you can make the definition. For example, if delta T is equal to 2, what happens here? 2 degrees Celsius. If you increase, when you supply the heat, what happened? The temperature is increased to what? 2 degrees Celsius. In that case, now Q is equal to C into 2, then C is equal to Q by 2. Now in that case, what will be the definition? What will be the definition? The heat capacity is equal to half of the heat supply. The heat capacity C is equal to half of the heat supply. You can't make a definition for this. So that is the reason they taken here 1 degree Celsius. Okay. So remaining what happened, I don't discuss because they are not in the syllabus. Just leave it these heat capacities because they are not in the syllabus. All these things are not in the syllabus. You can leave this one. Now let me go for what type of chemical reactions. I will show that one. Just a minute.